Have you heard about the ice cream cone theorem? I'm sure you haven't. This theorem is also known as tangent from an external point. This rule is a favorite in WAEC, JAMB and NECO. It looks simple, but it's powerful in creating a hidden isosceles triangle. Welcome to Post Scholars channel. I hope you're having a great day. So the title of this video is tangent from an external point, right? And we have just one question we are going to solve together. Now, before I solve this question, I'll need to explain the tangent from an external point theorem. Now, what does this mean? If you have a circle, right? Good. And you have an external point. I hope you are following me, right? Now, if you have a tangent from this external point to the circle, this is the first tangent, right? You have another tangent from the external point to the circle. This is the second tangent, right? Then you have the center, right? Now this is the radius, and this is another radius. Good. Now tangent from an external point theorem is saying that if this is point O and this is point P and this is point M, the theorem says that OP, distance OP or line OP is equals to line OM, right? The theorem doesn't just stop there. The theorem also says that the line from the external point to the center of the circle, right, bisect the angle between the tangents. What does that mean? It simply means if the whole of this angle is 60 degrees, now it becomes 30 degrees and what? 30 degree, right? So this is the underlying principle guiding tangents from an external point. Now with this information, we should be able to solve this problem, right? Now remember, I said the name tangent from an external point is also known as ice cream cone theorem. Now look at the ice cream. I hope you can see an ice cream here. Look at this, where you lick, and this where you hold. All right, now let's solve this problem. The question says, in the diagram QP and RP are tangent. You can see it simply means they are also what? Equal. Find the value of the marked angle X. And look at the angle X. So you are looking for this value of this angle, right? So let's solve. All right, very easy. The first thing you need to do is to analyze the diagram critically and start from what you know. Now we are given this angle, right? This angle is 35 degrees. Now from the principle or theorem of tangents from an external point, you already know that this line, right? This line is bisecting this angle. That means if this angle is 35 degrees, this angle will also be 35 degrees. So the name of this angle is RPT. So I'll say angle RPT is equal to what? 35 degrees. I can label it by putting it there again, right? Now, next, remember the mission is for us to find angle X, this angle here. Next, the whole of this angle becomes what? 70 degrees. But let's put the reason for this one. What's the reason for this one? In theory, always put your reason. The reason for this is angle at external point, tangent from external points. Can just put it like that. Right? Then the whole of this angle is going to be what? 70 degrees, because 35 plus 35. So I'll just say, and the name of this angle is QPR. That's QPR. So QPR is equal to 70 degrees, right? I can label it by putting it there again, right? Now, next, remember the mission is for us to find angle X, this angle here. Next, the whole of this angle becomes what? 70 degrees. But let's put the reason for this one. What's the reason for this one? In theory, always put your reason. The reason for this is angle at external point, tangent from external points. Can just put it like that, right? Then the whole of this angle is going to be what? 70 degrees, because 35 plus 35. So I'll just say, and the name of this angle is QPR. That's QPR. So QPR is equal to 70 degrees, right? Then remember the theorem I taught you in previous video, right? Tangents from a radius. Look at this is a tangent, right? And this is a radius. The angle subtended here, the whole of the angle subtended here is what? 90 degrees. Same thing. This is a tangent and this is a radius, right? Then the angle subtended here, the whole of the angle subtended here is going to be what? 90 degree. So we have 90 degree here, 90 degree here, then 70 degree here, right? Then look at this angle here. This angle is angle QOR. We don't know the angle here, angle QOR. So we are going to say QOR plus the next one is what? 90 plus 90 plus 70 equal to 360 degree. And what's the reason? Sum of angle in a quadrilateral. You can see this is a quadrilateral, although it's looking like a kite. You see it? First side, second side, third side, fourth side, right? And here is the QOR, this angle QOR. Here is 90 plus 90 plus 70, right? And what's the reason? We said the reason is sum of angle in a quadrilateral. So next, you have the QOR, angle QOR plus 90 plus 90 plus 70 gives 250, right? So you have plus 250 equal 360. Then you have QOR plus 360. QOR, let's just do it once. QOR equals 360 minus 250. Then QOR is equal to 360 minus 250 gives 110 degree. Now we have gotten this angle to be 110. There's no space to write it. So let's just, we know that this angle here is 110. Let's do it that way, right? Remember again, the mission is to find angle X. But if you look critically at this diagram, right? Let's extract this triangle out. So this is the triangle extracted out, something like this, like this, like this, and like this, right? Now we know that here is what? 110 degree, which is what we got here. Then this is an isosceles triangle. It simply means this side and this side are equal. Check it, this side, because this is a radius and this is also a radius, right? And all radius are equal. So I can represent it like this. This side is equal to this side. So automatically, this has become an isosceles triangle. Since it's an isosceles triangle, we know that the base angle are equal. And from this information, we know that this part of the angle is X. So I can label here X. Then if this angle here is X, this side also is going to be what? It's going to be X. So I'll label it X, right? The next thing to do is to sum up all the angles and equate it to what? 180, because sum of angle in a triangle is equal to what? 180. So let's do that. So we have X plus 110 equals 180 degree. What's the reason? Sum of angle in a triangle. X plus X gives 2X plus 110 equals 180 degree. Then 2X is equal to 180 minus 110. 2X is equal to 70 degree. Then divide both sides by 2, right? 2 cancels 2. Finally, X is equal to 35 degree, because 70 divided by 2 gives 35. And that's our final answer. You can see